I'm Ramón Zuñiga, a seismologist working for the National University of Mexico, Centro de Geociencias, which is located in Juriquilla campus in the state of Querétaro, Mexico. I'm very excited about working with the project that we have with Sigfox, and I will be telling you a little bit about the details. With regard to detection of earthquakes, we could talk about a very long history, because Mexico started detecting and registering earthquakes in the last years of the 19th century. And the first stations of the National Seismological Network started operating in 1910. So it's a long time since Mexico has been related to detecting earthquakes. In terms of the early warning system, which is the system that warns people about the incoming waves of an earthquake, that's also another interesting story, because Mexico was the first country to issue an alert based on a detection system. And this happened in 1993. And as I said, it was the first country to do so. And it has been doing that for continuously, successfully ever since, by people who work for cities. Originally was funded by Mexico City's government. Later, it has been receiving help from the federal government. But as I said, this is a project that started with people from different backgrounds, particularly also from the University of Mexico, the National University of Mexico, who pushed very hard for this type of project, because they thought that it would be something very useful for the population. So how do we estimate the threat of earthquakes in Mexico? We are still working on that. So it's not a problem that has been completely solved anywhere in the world. What we want to do is to be able to, in one thing, we have to know what causes earthquakes to full detail, or as much detail as we can. And that we are advancing a lot in that front, not only in Mexico, but in other countries. That would be the theoretical part as well as the observational part. But in terms of how to avoid the threat, we need to know, of course, the problem with complete details. But it's also a problem that involves the propagation of the waves through the earth, through the ground, and the reception of the waves at a particular site. And we have been doing very large advances, very great advances in all those fronts, but we are still a little bit far from responding to anybody who asks, how can I avoid the threat? I also want to say that there are two aspects regarding earthquake threats. One is the theoretical and observational part of the work and of the problem, and the other is the probabilistic and the engineering part of the problem. So I remember a very esteemed colleague of mine, Professor Sina Lomnitz, who passed away a few years ago. He used to say a phrase that I always have in the back of my mind, which is that earthquakes really don't do anything. They don't do any harm to people by themselves. What happens in terms of harm is that structures that humans build fall on top of ourselves. So if we can avoid this to happen, if we can avoid the structures to collapse during an earthquake, then there would be no threat. It's the same to say that if we are not living under a structure, we are just waiting in the open field and an earthquake happens, then there is no damage, of course. The pinpoints is, as I said, we need to know, from the theoretical part, we need to know more about how earthquakes are generated at different places in the earth. The second point is, how are waves propagated through the earth, and how they are then amplified, and well, there are many aspects regarding to propagation as well. And the third point in seismology is the reception of the waves at a particular site, which is to say, most of the times in terms of damage at urban sites or people dwellings and urban centers. There are two different aspects in terms of the data that we analyze. One is related to the process itself. And for that we need particular instruments which are called seismographs or accelerographs. These instruments record the motion at a particular point, and we need, for a detailed investigation of the process, we need the complete trace, or that is the complete time history of the motion. And that needs to be stored at some point, at some place, and we need to retrieve that data and analyze it carefully, and then we can derive some inferences from that. But in terms of the project that we are talking about, which is to improve the early warning capabilities of Mexico's system, we are not really after the complete signal. We just want to know when an earthquake is happening and estimate the approximate size of the event that is happening so that we can issue an alarm. That is really the basis of the current system. So we don't really need to know the actual magnitude, but we need to know that it's an event large enough to cause damage. So that's a little different from knowing the complete spectrum of the data. So those are two aspects which are a little bit separated, but can be also joined at some point because we can complement each other with data. Because the project with Sigfox will allow, if we can achieve what we want, we would have well, a very large number of observing stations, which is not easy to do with the complete signal, because these instruments, the instruments that I referred to before, are very expensive and are not easy to deploy. They need a particular installation, a place to install, some facilities in terms of communications, etc., which makes them very expensive. Opposite to that, the project with Sigfox is after very cheap sensors that can be deployed everywhere, mostly everywhere. And then we would be after a very large amount of data. The opportunity of working with Sigfox is quite exciting because, first of all, we have to be grateful that they came and offered their help. In particular, through the Sigfox Foundation, it's really a very valuable thing, because what they are offering is the capability of not only the communication of the signals, of the input signals, but also to develop a very robust system based, as I said, on cheap instrumentation, which can be deployed everywhere, and also can be, the type of communication is based on a separate network, which doesn't need to be dependent on current capabilities. So that also makes it affordable and would be something that can be used as an improvement of the current network, which, as I said, is difficult to maintain, difficult to operate, difficult to install. Thankfully, there are already quite a few stations. In terms of the current network, the number of stations is close to 100 right now, which is, as I said, a good number. But then if the project with Sigfox goes through, we would be talking about not only hundreds, but maybe thousands of stations all through Mexico. And then we would be able to issue alerts to other places where the alert is currently not being directed to. So it has many advantages in terms of the capabilities of the system, in terms of the amount of data that we want to acquire, and the possible uses for this data, as I said, are not only related to the early warning, but also to other seismological work. The project can be easily replicated in other countries, yes, because Mexico has already a very tough problem to begin with in terms of propagation, in terms of terrain, in terms of the vastness of the territory. If we can accomplish what we want with the installation of these sensors, then the project can be replicated anywhere, basically, in the world. And with the advantage that we would have already a test site, some place where we know the system is working and has been tested. And also the instruments, the sensors themselves, would be dedicated sensors, so that once the sensors are developed, they can be mass-produced. And of course, then again, the price goes down and they can be purchased by most anybody in any country. Mexico is one of the most active countries in the world in terms of earthquakes. We have in the order of one event every day, which is a magnitude 4 or larger. Some countries have a magnitude 4 every year, only one. For instance, countries in Europe. Mexico has always been, of course, interested in this problem because of the obvious repercussions. And science behind the study of earthquakes has always been also in the forefront of the scientific advances in the world. And this had been done in many cases by Mexican seismologists. Why is the project called Seconds to Save Life? What happens is that we are not really after predicting when an earthquake is going to occur. What we are after is to detect that an earthquake is already occurring, is starting, and for people who are located, I would say further than 100 kilometers from where the earthquake is occurring, there's still enough time for them, even though they are seconds, to do something about it. Those seconds are precious, really, so if we know how to use them. We, in the case of Mexico, Mexico City, for one, is located at a distance larger than 200 kilometers from the coast, which is where most earthquakes occur. Most earthquakes. Of course, we had already the unfortunate example of 19 September last year, and we had a large earthquake which took place within the interior of the continent, very close to Mexico, less than 100 kilometers away, and the warning was not enough then for people who were in the city. That's actually an interesting situation, and which is something that this project is going to attack, and that is the point that most of the detectors right now are located very close to the coast, which is the place where most of the earthquakes, the large earthquakes, occur. And since the detectors are located in that area, by the time the waves arrive at the detectors, they were already arriving at Mexico City. So, of course, that didn't leave people any time to do anything about it. So, in terms of this project, we are hoping that we will be able to deploy sensors all through the country, in particular in the interior of the country, so that we can issue warnings to anybody that are located at a distance that is useful. Well, as many as we can produce, that's the key point. We are hoping that they would be cheap enough to have, as I said, not 100, not 200, but maybe at least 1,000 to begin with. We will be doing that, of course, step by step. So that's a complete different situation than what we can do with any other instrumentation. Because as I said, in order to have just 100 stations of the other kind, then we would be millions and millions of dollars. The Internet of Things, it's a very interesting concept, And I'm pretty sure it's going to be a revolution in terms of many things. Internet of Things mainly relates to being able to communicate many devices, many objects that we currently have, and then use that communications to our advantage. So the avenues are open to anything that we can think of. The advantage in this project of using Internet of Things is that we are sending small messages which can be done in a very affordable manner through a dedicated network which is not related to the cellular phone network or the Wi-Fi network, which also makes it reliable and useful. I'm pretty sure that this is something that is just starting to cause the uproar that I'm sure it will cause in the following years, and many people will be taking advantage of the capabilities of this, the transmission of short messages through dedicated networks in all manners and things that we have not imagined yet. So, as I said, it is yet another revolution in terms of technical advances. It has not been easy to convince people to go and try to change their minds about the ways they have done things for many years, of course. That's always the case, of course, when you want to do something and you want to push forward in terms of progress. But fortunately, little by little, we have been convincing people of the advantages of this technology. And they have opened their minds to the ideas. And we are still working little by little to try to overcome small obstacles, of course. But it has been very productive in terms of what we have achieved. And also, it has been also very motivated thing to do this. And now, after talking to our friends and seeing that they are already excited about doing this, of course, then it's very satisfying for everyone who is involved in the project.